Welcome back, my dear students. In the last class, we have seen what is subnetting and then few examples for understanding the subnetting concepts. And this class, we are going to see about classful and then classless routing. So let me move on to the class. Right. So the first topic is CIDR. So classless interdomain routing. So before moving to this concept, you have to understand what is classful IP address. If you are having that five different classes of IP addresses like class A, class B, class C, class D and class E, then we are having some network port and then a host port in these classes of IP addresses, right? So if you are talking about the class full IP addresses, then we have to use the default network ID from the classes of IP addresses, and whatever the host address host port we are having, the same value we can apply for attaching the client machines to the network ID. Okay, so whenever that network systems want to communicate with other system, then it will use the same network ID which is defined by default. Okay, so what will happen here? Suppose if I'm using the class C or class A, class B. Okay, let me take the example of class A. So by using the class A, we can create the billions of IP addresses that we know already, right? So what will happen? Suppose I'm assigning this class A IP addresses to my lab system. So in our lab, we are having only 100 to 200 systems, right? But by using the class A, we can create that millions of IP addresses, right? So what will happen in this moment? We are taking only one network from the class A, and under that network we are going to connect only 200 to few hundred systems. That's it. So class A contains that billions of IP addresses, but still we are using only the 200 address, and the rest of the IP addresses will be wasted. Okay, so this is a problem when we are going for the classful router, classful IP addressing concepts. That's why we are going for the classless interdomain routing. So what will happen here? As per our requirements, we can reduce that network. Okay, we can extend the network ID, and then we can reduce that number of system also, right? And you see here one example I have given for the CIDR. Okay, so what I'm giving here, 192.0.0 sorry, 0.2.0/18. So here I'm using one notation slash 18. So what does that mean? You see here 192 is the range which is used in the class C IP address that we know well. Okay, but still I'm using that slash 18. So that means the first 18 bits are supporting for our network prefix IDs. Okay, that means for class A IP addresses, the default network ID is 255.255.255. That means the three first octet bits will be supporting for that network ID. But if you are looking for the three different octet bits, then it will give the values of 24. But I am using only 18 here. So I can reduce the network size, and then I can extend my client connectivities. Okay, so this is the advantages of when we are going for the CIDR. And you see here I'm giving some prefixes and the number of hosts which we can connect with that this kind of prefix values. Okay, actually these prefixes value will be starting from /31, and then it will be ending with /8. Okay, so /8 almost it is supporting for the class A type of IP addresses, and then that /31 which is used for class B as class C type of IP addresses. So just note down these values, because in the calculation we can use these kind of values and how many systems will be used for the particular prefixes, right? So you see here CIDR and address assignment. So I'm giving one example for assigning the IP addresses by using the CIDR concept. Okay, so the example I have given the question, assume that ISP owns the address block 206.0.64.0/18. So we know that this 206 is maybe it is class C type of IP addresses, and we know that the class C type of IP address is supporting for the 24 bits of network prefixes, but here we are using only 18 because I have given the notation /18. So I need to understand how many networks we can make with this by using these slash notations, and then how many IP addresses we can create by using this after assigning these prefixes. Okay, and you see in that line, suppose a client requires 800 host addresses. That means they are mentioning the client looks for only 800. If you're going for the slash notations, then we need to find out how many IP addresses, that means how many hosts we can create with the help of each and every slash notations. Okay, so if you're going to 2 power 9, then it will give that values of 512 only. So 512 address only we can create, but the client look for the 800, so we need to go little more. So then we are going to increase that n value from 9 to 10, so it will give the ranges of 1024. Now we have to choose this 2 power 10 only. So if you are choosing this 2 power 10, already we are having the IP addresses 32 bit value, so we need to subtract that 10 from this 32. So what we are having, we are having only 22 bit value as a host address places. Now we can change that values from this 22 bits, and then we can get that 1024 addresses for different systems. Okay, so in this way we can do calculate for each and everything. So now we can create the slash notation 22. So this slash notation 22, if you are going and refer for that prefix notation, then it will give the values of 1024 in the places. That's why I said, if you know the prefix values of a network, then you can easily calculate how much host address we can create by using these slash notations. The next one is IP version 6. So in the previous classes we had discussed something about IP version 6, and then what is the difference between this IP version 6 and then IP version 4. Okay, so as we know that earlier, that 128 bits will be supporting for this IP version 6, because that IPv6 length is 128 bits, and here we cannot use all these 128 bits as it is. Okay, there is some method to access the numbers and then hexadecimal values in this 128 bit. Suppose if we are having the continuous zeros, then we can remove all the zeros and then we can use scope operations with a single zero. That means we don't want to specify all the zeros in the IP addresses here. The same way, whatever that characters we are continuously having, then that similar characters we can remove, and then we can put that scope variable, sorry, scope operator, and then we can use that particular variable here. Now you see I'm giving the notation for IP version 6 addresses. So here I have mentioned that 128 bit addresses in the 16 different bit integer values. Okay, so here we are using the 16 bit values, and each and every bit values are specified with hexadecimal digits. Okay, so you see here nearly we are having the 16 different pots with the hexadecimal values. So if you are calculating this bit, then it will give that 128 bits of information. And how to write this, we are having one example addresses here, which is CEDF colon and then BP76 colon 4 times 0 again colon 4 times 0 again colon 009E and then colon 4 times 0 and then 3025 colon DF12. So now you see here, after BP76 we are having continuous 8 digits of zeros. So as I told you, we can remove these continuous zeros and then we can put 10 instead of that places. Okay, so you see here after BP76 the colon 0 and then colon 0 they are mentioning. So they are not using all that other hexadecimal values to represent these continuous zeros. Simply they are using 10 in that place. Okay, so if you are seeing any 10 in the IP addresses, it means that it is having the continuous zeros in that place. Okay, so in this way we can write this IP addresses in the IP version 6. Okay, but the same way we cannot use the IP version 4, so we can shrink that IP address length in the IP version 6, not in the IP version 4. And then IPv6 provider based addresses. That means if any provider giving this IP version 6, then with few notations we can easily understand, okay, whether this IP address is given from the providers or from some the internal users. Okay, so how to identify means the first field will contain 010, so it means that this IP addresses is given from some providers, okay, service providers. Okay, and then the next field is the registry ID, here we can understand which agency is going to be registered this IP addresses. Okay. After that, the provider ID. So this is the ID which is used for identifying the service provider for this registered IP addresses. Okay. After that, the subscriber ID. So subscriber ID is nothing but it is like a server. Okay. So whenever the client makes some request, that time that the server has to respond. So if the server got your request and it start to process, mean that machine is the subscriber machine, and then that ID will be attached here. And then subnetwork ID, we know that well what is the subnetwork. So it is the subgroup of our the large network, right? So that subnetwork ID will be specified here because we are having the large number of subnetwork, and then we need to find out which system is present in the particular subnetwork. Okay, to understand the system destination address place, we need to find out this subnetwork ID. And finally we are having the interface ID, which is nothing but our system ID. Okay, so after finding that subnetwork ID, that packet should be reached to the system, the destination system. Okay, so that packet will be reaching through this interface ID only, so because it is the original logical address of our machine. So it will find that machine and then it will reach to the system or to the services. So this is the notation or the fields which is available in this IP version 6 provider based addresses concepts. And the next one is the beginning itself I have told what is the classful routing and then classless routing, right? So here I'm giving the table of classful and then classless routing concepts. First one is it is applied for the addresses. The classful routing, we know that it has a three different parts, right? So one is the network part and then subnet and then host. So you see here the classful, the name itself telling that total network ID will get that class full. Okay, so if you're creating any network by using some classes, then the whole network will be used for this. Okay, the default network ID will be used for creating the network. So what will happen here, as I told you before, if you are following the default network ID, then we have to waste many IP addresses in case if you are going for making the small client connections. Okay, but if you are going for a classless, then we can shrink that IP addresses, and then we are having the subnet and then prefix value. So if you are using the prefix, then we can simplify, we can manage the wasting of IP addresses in the networks. Okay, so it is better we can follow the classless routing instead of classful routing. And then the difference between FLSM subnetting and VLSM subnetting. So it is nothing but fixed length subnet mask and then variable length subnet mask. It is based on that classful and then classless routing only. Now we will see the points of fixed length subnet mask and then variable length subnet mask. So whatever the points we have studied in the classful and then classless routing, the same points will be covered here also. You see all the in the FLSM they are mentioning all the subnets are in equal in size. So I told you that, right, because it is using that default network ID. So if anything following the default network ID, then all the subnet whichever created by that particular class, then the length of that subnet is equal, right? But if you're going for the variable length subnet mask, then automatically the subnet counting also will be getting varied. Okay, for some networks we can use that minimum number of subnets, and then for some network configuration we can go with a larger number of subnets, but all the subnets will be created under the same classes of IP only. And the next point is all subnets have equal number of hosts, right? Because we are having the equal number of networks, right? So under that network we can create the same host configurations, because for example I'm telling for class B, if you are taking the IP addresses, then what will happen, the 255.255 is that network ID, and we are having under dot 0.0, right? In this 0.0 place we can create the client connections up to 0 to 255.0 to 255. That means 65,535 systems we can connect in that each and every group of network. So it is constant. But if you are going for that VLSM concept, then based on that network prefix value, we can create the client connectivity. Okay, so that's why we are telling it has the variable number of host connections. Then the third point, all subnet uses same subnet mask. Yeah, because we are not going to touch or we are not going to borrow any extra bit from the host places. Simply we are using the default network ID, right? So if you are using the default network ID, then there is no need of creating the different subnet mask. But in the VLSM concept, we are just extending or we are shrinking that network ID, right? So that moment we have to give this prefix mask value. So that's what we are telling. We are in VLSM, the subnet will use the different subnet mask values. And the next point, it wastes lot of IP addresses, right? We know that field, right? Because the classful IP addresses, we are wasting the loss of IP address. That's why we are going for the classless inter-domain routing. So you see, obviously we can say that by using the pixel length subnet mask, we are wasting the IP addresses. But if you are using that VLSM, then the wasting of IP addresses will be very less only. And then next point is, it is also known as classful subnetting. Already I have told you that, right? If the classful subnetting means it is just FLSM only. And then final point is, it supports both classful and then classless routing protocols. Yeah, what are the routing protocols we are used here? That will be supported for classful and then classless routing. And if it is a pixel length, that means the classful subnetting, then automatically it will support all those protocols only. And if you are looking for that VLSM concept, only the classless routing protocol will be supported, because we cannot use the classful IP addresses here. So we are creating some different prefix value, right? So based on that prefix value, the different protocols will be applicable in classless routing functions. That's all about your module 2. In the next class onwards, we are going to see about the module 3. Thank you.